What is up, you guys? It's Miss Dupe. I am here to talk to you about scientific notation and specifically changing from scientific notation to standard notation. And today I have this beautiful presentation because Miss Bofice was starting to make me look bad, so I had to make a pretty presentation today. So first off, we are going to talk about what scientific notation is because you might not be familiar with it. So scientific notation is a mathematical way to express very large or very small numbers. So it is taking numbers that we could write in a normal way and writing them in a shorter form so that they're not so annoying to write. It's normally numbers with a lot of zeros on them. So for a couple examples, 6.7 times 10 to the first is in scientific notation. 3.46 times 10 to the second is in scientific notation. 3.35 times 10 to the negative first is in scientific notation, and 7.3 times 10 to the negative 6 is in scientific notation. The thing that makes these all numbers in scientific notation is the times 10 part on each of these numbers. So the times 10 part on each of these numbers is what makes scientific notation scientific notation. You will never not see times 10 on a scientific notation number. The other part I want to discuss before we move on to the next slide is some vocabulary. So the number in front of the times 10 I just normally call our front number, but the number after that, the times 10 to the first or times 10 to the second, these have specific vocab that goes with them. The 10 is called our base, and I like to think of our base as what holds up our small number, which you probably already know are our exponents. Well, this is just one exponent, so let's not put an S there. So in every single one of these, you should have a base of 10. Scientific notation has to have a base of 10, but your exponent may vary. So 6.7 times 10 to the first has an exponent of 1. This is an exponent of 2. This is an exponent of negative 1, and here's an exponent of negative 6. So moving on, we're also going to talk about what standard notation or standard form is. So we kind of use notation and form for standard interchangeably, so that's why I have a slash there. And standard form is how we traditionally write numbers. So just normal numbers that we write. For example, 34, that's standard notation or standard form. 79,700 is normal standard form. 0.0121 is also standard form. It's a decimal and it's standard form. And 0.29 is also standard form. So next we are going to talk about the steps to change from scientific to standard form. So this would be a situation in which we have a number in scientific notation and we'd rather see it how we would normally see it. So our first example, we're going to start with 6.1 times 10 to the fourth. So starting out, when we want to change from scientific notation to standard notation, we are going to look at the exponent. And the exponent is going to tell us how many place values we need to move the decimal point. So in this problem, our exponent is this 4 right here. So we're going to end up moving our decimal point 4 places, but we don't know which direction to move the decimal point yet, so we're going to find out. So here it says if the exponent is positive, we're going to make the number larger. So we are going to move our decimal in a way that makes our number larger. If the exponent is negative, it's going to make the number smaller. And just so you know, when I say the number, I mean our front number. So we're going to start doing this one. I'm going to write 6.1 below here just so that we don't get it mixed up in the other stuff here. Now, like I said, we have an exponent of 4. So we are going to take this decimal and we're going to move it 4 place values. And since it's positive, which it is, we're going to make our 6.1 a larger number. So in order to make this larger, we have to move our decimal to the right. I don't really like you guys memorizing right or left, so I just say make the number look larger or make the number smaller. So we're going to take our decimal and we're going to move it 1, 2, 3, 4 times to make this front number a larger number. And then after we move it 4 times, since our exponent is 4, we're going to put zeros in the empty spaces that come up. So our final answer for 6.1 times 10 to the 4th, written in standard form, is going to be 61,000. So 6.1 times 10 to the 4th and 61,000 are the same exact number, they're just written differently. So our next number that we're going to take a look at is 8.651 times 10 to the 7th. So once again, our exponent tells you how many place values to move the decimal. Now, instead of filling out this bottom part over and over again, let's just take a look. Our exponent is 7. So our exponent is definitely positive. So just a reminder, if the exponent is positive, we're going to make the number larger. And by the number, we mean the front number. So we're going to take 8.651, and we are going to move the decimal to the right, which is the direction that would make 8.651 larger. We are going to move this decimal 7 times since our exponent is 7. So we're going to start at our decimal point and move it 1, 2, 3, 4, 5, 6, 7 times. And then in the empty spaces, we fill in our zeros. I would like to point out, some people start thinking that the exponent matches how many zeros we have, but just notice our exponent is 7 and we have 1, 2, 3, 4 zeros, so that is not true. So our final answer, 8651, we're going to add our commas in. If you didn't know this, you count from the back of the number every 3 spaces to put your commas in. Oops, that's the wrong place though. So this would be 86,510,000. It's a pretty large number. So now we're going to work on some examples that make the number smaller. So we're going to start pretty easy. Let's do 3.35 times 10 to the negative first. So once again, the exponent tells you how many place values to move. And then if the exponent is negative, which it is in this case now, it's -1, we are going to make the number smaller. So we're going to write our front number down, which is 3.35, and we're going to take a look at our decimal point. That decimal point only needs to move 1 time since our number is -1, but since it's negative, we're going to make our number smaller by moving the decimal to the left. So we're going to take that decimal point and move it 1 time. Now here, we're going to make a new decimal. Our other numbers, since they were whole numbers that we ended up having, we didn't have to leave the decimal point. But here, when we're making them smaller, they're becoming smaller decimals. So our final answer is going to be 0.335. Our last example, we're going to make it a little bit more complicated. So we'll do 7.3 times 10 to the negative sixth. So once again, the exponent tells you how many place values you need to move the decimal. Look at our exponent, it is negative 6. So since our exponent is negative, we're going to make the number smaller. So we're going to write down our front number, 7.3. We are going to move that decimal so that it makes our number smaller. We're going to move it to the left, and we're going to start at our decimal point. So starting at our decimal point, we're going to move it 1, 2, 3, 4, 5, 6 places. We're going to mark our decimal point in the new spot, and then fill our empty spaces with zeros. So even though our exponent is negative 6, we only have 1, 2, 3, 4, 5 zeros. So our answer is 0.00000073. So as you can see, scientific notation kind of helps us avoid writing all those zeros, which is really helpful. And that is how you change from scientific notation to standard notation.